Hello. Let me wind this down here, and then we'll do this. If you can hear my voice, that means it's time for chemistry. Yay. Hi, everybody. Welcome to Chem 161. I'm your host, Wes Hillman. My degree is in inorganic chemistry. Most of you probably already know this because you probably took 140 with me. You're in good hands, yada, yada, yada. So, for those of you that don't know me, hello. Please address me as any of the following. These are all fine. I'd like first name basis. I call you guys by your first name because that's what's literally written on my roster. So please feel free to do the same. You can call me professor. That works too. It's not technically my title. My technical title is faculty, but calling me faculty seems weird. I had a student call me boss, and I was like, I'm going to put that on the list. That sounds good. And then I'm a huge nerd, so whatever derivative of orc you want, that works for me too. Just don't call me Mr. Hillman. It makes me feel old. Soon I'm just going to come to terms with it, and I'm going to have to delete that from my slides, and then I'm just going to be really sad, because that's been there ever since I, started teaching. All right. You can reach me at the email address on the screen. I am giving you this email for you to write down in your notes, just in case you want it, for the reason that Canvas is not always functional. Sometimes Canvas goes down, and you can't do anything through it because they're trying to update the database, or something broke and they're trying to repair it, or so on. And you still might be able to, or you still might need to get a hold of me. Other times, Canvas is just slow, so on the first few days of classes, it tends to get backlogged, and it doesn't always send things out super quickly. This is particularly a problem in fall quarter. Spring quarter has been pretty good so far. So, hopefully there won't be any issues with this. But it has happened in the past. And if you need to get a hold of me and be assured that your email went through when you sent it, use a different email account, and then just send it to that email. Let's see here. If you want to contact me for any sort of office hours type inquiries, so I don't have physical office hours on campus this quarter because I'm still teaching remote. I do accept requests for meetings via Discord. So we do have a class Discord channel, which is up. It looks like there are a lot of students that are in there. Someone already pointed out, hey, there's a mistake in the syllabus that says we were meeting at 2:30. Or not 2:30, I'm sorry, at 12:20. And oh, yep. Copy-paste error. Thanks a lot. This is what happens when you have to write 3 syllabi. And you just start copying and pasting everything. And don't remember to edit one thing in one of them. So yeah, this is our correct class time. It is at 2:30 to 4:20. And if you have any questions that you need me to address, please feel free to email them to me or use Discord. You can @me on Discord, or you can send me a private message. I believe that a student has put up a separate channel for homework help. And then there's an off-topic channel. Yeah, there's all sorts of stuff in here. So use the channels however you see fit. I'm going to usually just post announcements in the channel that I feel are relevant but don't warrant me spamming your email, such as, hey, there's a lecture and it's starting now. I do that for the first week, and then after that I just poke you in Discord. If that helps you, great. If it doesn't, you can mute that. Or whatever. So, but if you want to talk to me and you want a place for me to copy and paste pictures and stuff, Discord is the place to go, because I can take, where is it? So I have this screen available here. Let me make this smaller here. But this is my whiteboard that I use. This is really just Photoshop. But if you ask me a question and have a solution, I can write out the answer on here however I want to. Then I can just copy and paste it into Discord in seconds, because I can just hit the snapshot tool, and then you have your answer immediately, as opposed to me pasting it into Google as a JPEG or whatever, sending the file, waiting for you to get the file, and then you commenting back, and then us making a giant thread where that picture is just gone because I don't know where it is. So I find Discord to be much easier for answering student questions. So please, please, please use it. All right. Because this is Chem 161, and you may or may not have taken Chem 140 beforehand, there is a probability that this is your first chemistry class at the college, and you don't know how Canvas and all of this work. So we're going to go through this process here. Let me get... Oh, you know what I can do? I can just click on it, can't I? And we'll just drag this over here, and then I'll put it on the screen so you can see it. Boop. Oh, that's a little too big, isn't it? All right. So when you open up Canvas, you're going to get a page that looks kind of like this. With all of your courses. Look at all the classes I'm teaching this quarter. It's so ridiculous. Here's us. We're blue. I'm going to click on 40012. And it looks sort of like this. This isn't wide enough, I realize. So my view does look a little different. I have more things. For example, you won't be able to see all of these buttons down here because they're hidden. Because I don't know what half of these do, or I don't use them. The page that is most of interest to us is the Modules tab. And inside the Modules tab, I guess this still isn't wide enough. There we go. Inside the Modules tab, initially will just be this section right here. So we have a link to my YouTube page. Here's the lecture archive. So this is where all of our lectures will be saved. You just click on this link, and then it will follow you. Oh, I could just do this. So there was only one lecture so far. It was the test stream. After today, this lecture will appear right here. And it's just chronological, and it will just go straight down the list. So if you are looking to watch a bunch of lectures at once, this page will help you. I have a bunch of other links and resources here. And then down here, all of this stuff is going to be locked until you do this assignment right here. So I have an orientation activity that I do require you to do. You need to score 100% on it, which means get all the questions correct. Once you have done so, all of the remaining course materials will unlock. And so here are those materials. So we have different lab worksheets for the assignments that you're going to be doing in this class. And then finally, I have all the different chapters we're going to cover in this course, which is chapters 1 through 6. And you'll notice that we go 1, 2, 6, 3, 4, 5. That is intended. That is the order of the chapters we're going to do. We're going to do 1, 2, 6, which is going to be all the review stuff, more or less. And then we're going to do 3, 4, 5, which is where the class takes a very drastic turn into the crazy, because we're going to talk about quantum mechanics and all that weird goodness. So the first 4 weeks or so are going to be 140 review, more or less. And then we're going to get into the new stuff, and the class is going to take a drastic turn for the difficult. So we're going to talk a little bit more about that as I talk about class structure later. But what we're going to do here is we're going to talk about the syllabus, which I thought I had loaded, actually. I guess I didn't. Oh, no, I didn't actually click on it. So let me get this all set up here so that you can see the syllabus. Syllabus. There we go. And we don't need this there. All right, so on the screen here, you can see the schedule. It mostly fits. I could just do that, I guess. On the right are things that are assignments or due, or events that are important to attend or whatever. For example, this week, the test stream was on Sunday, so hopefully you made it to that. Almost nobody did. Don't worry, it's fine. You can watch me play Mario on later if you're just bored. I don't know. Or watch a better YouTuber. On Friday, the orientation quiz is due. Make sure that you have completed that by Friday. If it looks like you have not attempted the orientation quiz, I will drop you from the class. If it looks like you've attempted it but don't have 100%, you'll get an email that says, hey, you need to finish this, or else you might be dropped from the class. So just do note that. Make sure that you don't put this class off for a week, because I will drop students from the class that look like they have not attended for the first week. The general order of chapters that we are going to follow is shown here. There is a quiz on a per chapter basis. So after we finish chapter 1, the chapter 1 quiz will go up. After we finish chapter 2, the chapter 2 quiz will go up, so on and so forth. Those quiz dates will be due after we have finished the chapter. So you'll have a week after we finish chapter 1 before the first quiz goes up. That'll probably appear week it'll appear week 2 and it'll close week 3. Then chapter 2s will appear the next week, and then chapter 6s will appear the next week, and so on. We also have some exams. The exams are written in bold, so be mindful of those dates, because you will be required to do your exam on those dates. We'll talk a little bit about exam flexibility later on in the quarter. But that's the general structure of the course. Here are the assignments that you're going to be doing and their point value. So there are 550 points in this class. Quizzes, there are 5, 25 points each. Exams, there are 2, 75 points each. Labs, there are 5, 25 points each. And then finally, the final is 150. Quizzes are much more point-rich than they were in 140, and there are fewer of them. So be very mindful that the quizzes have much higher stakes this quarter. Also, the percentages that you need slightly taper upward as you progress through the Chem sequence. In Chem 140, I require a 72 to get a C. Now it's a 73, and by the time you get to 163, it's a 75. So you do have to do progressively more and more effort for harder content, admittedly, to get the A that everybody wants. This is by design. I do want you to work harder and harder as you go on. I don't know what an A would be in organic if I taught it. Not 99. I don't think I'd go above 95. But I'd probably go back down, because organic is just ridiculously hard. Finally, here are some useful links here for students. The student rights and policies link leads you to the student handbook, which basically is going to point to the section on academic plagiarism. Do not cheat. I will find out. Canvas. Canvas is what we are using for all of our online storage, and quizzes and stuff like that are all on there. All your grades will be on there that you can access. It's our online learning management system. If you have an issue with Canvas and you can't log in, click on this link. My cat's just messed up this blanket. Hold on. This is why cats are an issue. Okay, there we go. Where was I? Sorry. If you have an issue with Canvas, make sure that you email eLearning. For example, if you can't log into Canvas, I can't help you. I don't know how to reset your password. I don't know how to debug that, but they do. So make sure you email them. They cannot do this at night, for what it is worth. Hannah is not up at 9 p.m. to help you debug why you can't log into Canvas. So if your exam is due that night, I can't help you. And that's going to be inexcused. So make sure that you are able to log into all of your stuff and everything is working. And if it's not, contact Canvas immediately. The Tutoring Center, I strongly recommend if you feel like you are falling behind in this course. We have a chemistry tutor. Her name is Candace. Candace is amazing. She can do everything I can and more. We also have other chemistry tutors that are previous students, not necessarily of mine, but they completed chemistry with a high grade, and I would vouch for any of them in the Tutoring Center as capable and competent and worthwhile of your tutoring time. So if you have questions, please contact the Tutoring Center. We have both in-person tutoring available and online tutoring available this quarter. In person, I believe, is Rainier 119. Oh, it says it right there. Rainier 119. The online stuff is at the Tutoring Center website. We have a Canvas page for that, and you can do drop-in Zoom tutoring, I believe, is available. Writing Center, not super important for this class because you're not going to be doing very much written lab work other than like just write a paragraph or two in a lab worksheet. And generally speaking, that's okay. The IT Help Desk link is there for you in case you have issues logging into your My EVCC, your student email. All of your password stuff fails and you have to like reset it globally, stuff like that. IT Help Desk and e-learning are kind of tangentially related. If you have issues with something infotech, email both, unless you know that Canvas is not involved, in which case just email IT. Somebody will be able to help you. If it's Michael, he will do a great job. Michael is my IT go-to guy. Michael or Bill, I should say. What else do I need to note here? So prerequisites for this class, I am in the process of enforcing these prerequisites. Note, if you did not complete 140 last quarter and you are here, you will be dropped. I will be working on that over the course of this week. You do need to have completed 140 with a C or better. I do require that. If you did not complete 140 but you enrolled because it let you, I am currently working with somebody who is going to go through all those prerequisites, and I will drop people who have not met those prerequisites. So, you are required to meet these prerequisites, have either completed Chem 140 or taken a high school chemistry with a C or better, or have completed Calc 2 with a B plus or better. The last thing you can do is you can take the Chem placement test and be placed into 161. If you have not completed 140, I don't know if you are eligible for that. Or what I mean is, if you have taken 140 but then did not pass it, I do not think that you could take the Chem placement test. So I do enforce these prerequisites, so I will be looking over those. I know that that hasn't kicked anybody out of the class yet, but that is a work in progress, so that is just, I'm just letting you know that if you did not pass 140, I will be dropping you. Or if you do not show up for anything this week, so just FYI. What is the textbook for this class? So we have this OER textbook that is actually surprisingly good. So if I got to add a window here. Hold on. Window capture 7, I guess. Okay, and this is what I want. So let's see here. So if you click on this right here, likewise, you could click on any of these. Let me go back here. Any of these other links in the chapter will lead to specific chapters. But if we go here, and we'll just open this in a new tab. This is our textbook. The textbook is entirely online, and it is actually very good. The previous textbook that I taught out of cost like $200. This one is free. So we have managed to create a course that uses this online textbook for everything that we need to, and still accomplish all of our learning objectives and course outcomes. And I like it better. Like, it tells a better story than the first one did. And I feel like that's difficult. So if you go to the table of contents here, we're going to be doing chapters 1 through 6. And so all of those topics are listed here. If you just want to look ahead, Chem 162 is chapters 7 through 12, and then 163 is 13 through 17, and then 20. So we do all sorts of stuff. We do almost the entirety of this text. So we're going to start here. Chapter 1 is going to just be basically the essentials of chemistry, which is basic math, basic dimensional analysis, what does matter, that sort of stuff. We're going to do that today. You can read through all these sections, and then at the end of each section are exercises, which you can then do for practice problems. And so there's our practice problems right here. So unlike in 140 where you had a workbook, this is your workbook. You're going to be using this online text. Odd numbers do have solutions. You can click on the answer, this right here, and it will take you to the answer key. Note that the answer key does not have any context in it. It just tells you what the answer is. I do not care about this. I'm just trying to unhighlight something. There we go. If you have further questions, you can always just ask me about it. So just something to keep in mind. So that text is required, but it is free. You will need a calculator of some sort that has these functions. You could see them down here. So you're going to need a calculator that has log, natural log, 10 to the x, xy, times 10 to the, so like 5 times 10 to the 2 is 500. So that's how I use that. I don't need any of those functions. Oh, e to the x, we're going to use that at some point. Not necessarily in this class, but we're going to be using a lot of algebraic functions in this class. So I have this calculator handy because I realized, I can just put a calculator on the screen. Duh. We're going to be doing, I think the most complicated calculation that we're going to be doing in this class is just use the inverse button. So wherever my 1 over x button is there. Yeah, we're going to use that when we talk about wavelengths and stuff in chapter 3. Chem 161, not super calculation intensive. In fact, once we get to like week 4, we put the calculator away and you never touch it again. except for like one or two exceptions. Um, this is the one chemistry class that does not have a ton of math in it. We're going to do the math up at the front, and then we're going to just sort of not do it again. You will be responsible for math more or less in the laboratory sections, which is where we're going to do a lot more of the analytical work, which again is why we do Chapter 6 before Chapter 3. If you do not have a calculator that meets those descriptions, you can use Wolfram Alpha again. That is still handy from last quarter. It always will be handy, and you can use that for any exam or quiz that you want. And then also P-table is particularly good for periodic table. We'll get to that pretty shortly, because I believe we talked about the periodic table in Chapter 1. Very important, if you have the old version of the syllabus, i.e. before like 2:30 today, this table right here was wrong. It said 1220 to 210, which is probably why a lot of you showed up for my 121 lecture. I apologize for that. This is an artifact of I have 3 syllabi, and I'm copying and pasting shit and trying to make everything look the same in all of them, so I don't have 3 different syllabi. I didn't get around changing this table, so it has been corrected. This is the correct class time, which is shown up here at the top. Right here. And also in the course catalog. Lecture attendance is optional. I do not require you to be here at lecture. I do not take attendance for lecture. That being said, try to make it to lecture. I have found that in the past, if people show up to lecture, they are more likely to pass the class. Last quarter, I had like 2 or 3 out of a 25-person class attend one of my lectures every day, and they did reasonably well in the course. And I had a lot of people who didn't show up to lecture, just didn't make it. The reason for that is going to be a time issue. As the quarter progresses, if you start missing lectures, they pile up and they don't go away. They sit on your plate until you have watched them. And if you get to the exam day and you're like, shit, I still have 5 lectures to watch, they're all 2 hours each, you're not going to make it, dude. Like, that's too much stuff. You don't have enough time. Likewise, if you are working 40 hours a day and you miss the lectures and then you're tired afterwards, so you don't watch the lectures until the weekend, you're not going to have enough time, right? Where's all the time that you're going to practice the problems, because more lectures are coming. So if you can, and it is within your ability to do so, make it to these lectures. It is worth your time in the long run, because the more time you put into this class, the more successful you will be. It is purely a function of effort and time. YouTube. I had to ban someone from my channel last lecture because they were spamming it. So I had to look up how to block somebody, and that was particularly funny because they were typing things like, haha, you can't block me, and then I hit a button and timed them out for 300 seconds, and then they were gone forever. So, yeah, if you're an asshole and you spam my chat, I will ban you. If you are actually a student doing that, you won't be able to watch my videos anymore. And that is probably not in your best interest. So do not get yourself banned. Don't be an ass. Be friendly to other students. I do have it set so that you cannot post links in the chat or anything that is considered spammy. The system will try and filter it, or will at least alert me. If there is something that you need and it requires a link, I will paste it in the class Discord so that you have it. Or you could paste that for me in the class Discord if you need to. All of these lectures are archived forever. So again, you can watch them afterward, but I strongly recommend that you watch these during the time that I offer these lectures. Homework is all in the OER textbook, and I'm not grading any of it. It is all for your own practice. You do need to be the executor of your own time. Make sure that you are putting in enough time. Do the practice problems in the OER textbook. There are tons of them, and they are very good practice. If you have done all of the problems and you still don't feel comfortable, do them again. They are not produce. They do not go bad. If you have done the problems and you're like, oh, I know how to do this problem, I've done it 30 times, congratulations. That's called learning. That's what I want. I want you to be able to do those problems without even thinking about it. Are there extra worksheets and stuff? I don't have them for this course. I will see if I have anything I can put up online. But it will take time to construct those if I don't have them, and I may just get swamped. I am currently working 200% this quarter. I am teaching 5 classes, so my availability will be somewhat limited because I will basically just be in grading hell once week 2 starts. So I will do the best that I can to provide extra support materials, but if they aren't available, I'm just going to say they're not available, and I apologize for that. Let's talk about quizzes. So quizzes in this course are all online, just like in my 140. If you have taken my course before for 140, you know how the quizzes work. It's the same principle. You're going to answer a series of online questions. You have a time limit to do them. And the content will be presented in the same manner. So one question at a time, no backtracking. Answer the question and move on, or just skip it and you don't get credit for it. Time in this class is a much tighter constraint because in 161 I expect that you are operating at a much higher level than 140. So for your quizzes, you're going to have 30 minutes for a chapter quiz, but there are only 5 quizzes, as opposed to the 10 quizzes that you had last quarter and still got 30 minutes for. So you are going to have to do more stuff faster. Keep in mind that you may use any material you want. That stipulation has not changed. So you can use your notes, you can use your practice exercises from the homework in the OER text. You can use any resources that are available to you. If you go hunting for my problems on the internet to try and solve them by like getting the answers from, I don't know, any website that provides that, you will time out. You will run out of time and not finish the quiz, because if I can't find them in time, you certainly won't, right? And I know what the problems are because I wrote them. So don't go hunting for, has this question been asked? Is there this stupid question about this half-orc with a treasure chest full of coins? How do I solve it? We all remember that from 140. Yes, you might see it again. It's still in the pool. No, you will not find it online in time because you only have 30 minutes. So the best way to get around quiz problems is to know how to solve them by doing as much practice as you can and then actually doing them. So go for the path of least resistance. Just study the material. That's my honest, sincere advice. As far as quiz attempts are concerned, you do get 2 attempts, just like before in my 140. I allow you 2 attempts for any online assessment because I cannot dictate or guarantee a safe testing environment for you. For instance, the power might go out, or your cat might throw up, or you might suddenly get a phone call that takes you away from your quiz. If that happens, you get a second attempt, and it's already programmed in there. I allow 2 attempts for all assessment in this class. No questions asked. If you do the quiz or the exam the first time and you're fine, you think, oh, okay, great. I did everything I wanted to. Everything is wonderful. Then you're all set. You don't have to worry about taking the other attempt. If you think you did poorly the first attempt, take the second attempt. It's there for that reason. So if you miss an attempt for any reason, like you have to close the window or your computer reboots or Canvas crashes or whatever, that counts as your first attempt and you get your second attempt. If you go through 2 attempts and still have issue, you need to email me immediately, and then I have to go and look in the log and see if it warrants me giving you another attempt. I'm going to try and work with you on this. Like, obviously, if Canvas crashes on Monday and on Thursday, and your exam was due Saturday or something, and, like, it just happened to be, like, oh, those are the times I tried, and it was down, so I couldn't do my quiz that day, or whatever, I can work with you on that. If you email me at 11:54 saying, "Hey, I couldn't get into Canvas today and I just got on," I'm going to say, "Well, why didn't you take your quiz earlier?" And you're not going to be able to get an extension for that. So, don't do stuff last minute. Exams are like quizzes, but they are longer and they are on 2 specific days in the syllabus, and then the final exam is the longest and is available on the day of the final. So, we'll talk more about the exams and the final when we get there. But for now, don't worry too much about those. We'll just worry about the quizzes and then the labs later on when we get to them. So, on the screen is the laboratory schedule. Every other week, we will do a lab worksheet. We are not doing in-person labs for 161 this quarter. I believe we're going to start doing that again in the fall. But for spring quarter, this is all online still. I have created a series of worksheets that are modeled after the labs you would have done in the laboratory. However, all of the experiments have been done for you and the data has been collected by me, or I have found adequate videos that record that information. And so that is all available in the links in these documents. You're going to turn in a Google Sheet just like you did in 140 for my previous class. It's all the same. If that is all news to you and you don't know what that means, don't worry. We'll talk about it next week when we talk about lab during week 2. So we'll come back to that. My late work policy is that there is a deadline for quizzes and labs. Exams and final have a very strict deadline, so if you miss the exam by the time it ends at the end of the day, bad things happen to your grade. But for quizzes and lab worksheets, I will set a due date on the calendar, and that calendar will appear on your Canvas. So when you go to your calendar, it will say, hey, this is due on this day. That deadline that appears for my stuff is a soft deadline. If you miss that deadline, you still have a 24-hour grace period afterwards to finish the assignment and submit it. Your assignment will be marked as late. That is okay. I ignore that. If you miss the late deadline, i.e. the 24 hours after the calendar date, there will be a last call email that goes out 6 hours before the assignment closes. If you miss the closing deadline, shit out of luck. The assignment is closed. You do not get to make it up. So I give you a soft deadline, I give you a last call deadline, and then the assignment closes. If you miss all of those, I can't help you. Your assignment is closed. It's worth nothing. I do not accept late work. If you email me saying, hey, I missed this by 5 minutes, I will just email you back saying, hi, the deadline was 11:59. And that's all I will say. And you will not get credit for it. I do not accept late work for any reason. Do not miss the deadline. If you miss 5 things in this class, I cannot pass you. Oops. I didn't mean to do that. So please don't miss assignments. Make sure you are on time because there are a large number of assignments and they will have various deadlines at various times. So be on top of things. Don't just let the class coast for a week and then come back and check it on it. Now, all of that said, I do let you use the NQA policy for one missed assignment, not a quiz, or I'm sorry, not an exam, not a final. So quiz or lab stuff, if you miss the hard deadline and the assignment closes, and you email me saying, hey, can I turn this in late? I will say no, the assignment was closed. If you say, can I turn this in late with my NQA? I will say, yes, I will grade this as if it was on time, because you get 1. Everybody gets 1 oops. And that's what the NQA policy is. If you miss 1 assignment for any reason, all you do is email me and say, NQA, I need to NQA this 1 assignment. And I'll say, okay. You do not need to give me an excuse. It is no questions asked. Your excuse can be as varied of a range as, I simply forgot to do it, to my grandparents died. However, I am obligated to require that the first thing that you miss is NQA. So, obviously, hold on. Sorry. Dropping frames, because I have Comcast and it sucks. Okay. So, just to repeat what I said, because it cut out there for a second. I do require that the first assignment that you miss is NQA, regardless of the reason. So, obviously, one of the excuses that I mentioned before, grandparents dying versus I overslept or whatever, one of those is much more legitimate than the other. But in the interest of equity and everybody being offered this policy, the first occurrence, I do have to require that you use this NQA policy. If there is a second occurrence, then it is by my own judgment and by any evidence that you can submit to me. So if you are in the hospital for 3 days and you miss 2 assignments, then yes, I will work with you on that. If you simply have no excuse for why you missed 2 assignments, then no, I will not. Okay, so I will use my judgment afterward if you have a particularly compelling reason why you are missing assignments. But for the first one, everybody gets a freebie regardless of what it is. And you can make it up. You've already read about your grade at the start, so you could read all this stuff on your own. So the last two things I really want to comment on are, if you have CDS accommodations, please send that information to CDS. That will be then sent to me, and I will get all of that set up for you. If there's anything that I need to do to help make your time in this class more accessible or more helpful for you, please let me know. And then the academic honesty policy right here. I evicted somebody from the not evicted. I expelled somebody from the class last quarter because I caught them cheating. They tried to do it twice. They failed the class and were removed. If you submit something to me that I suspect there is evidence of cheating for any reason, particularly lab reports, if you submit a lab report that I am either fairly certain you have plagiarized from another student or am absolutely certain for various reasons, none of which I am going to disclose because I have put out what I will call traps, I guess, to catch students who are trying to download shit off of Chegg or whatever. I will find it. I will absolutely find it, and you will be expelled from the course. Okay? I immediately submit any suspicious papers to behavioral intervention. You get a message from the dean saying, "Hey, come talk to me. I want to know why you're cheating in Wes's course." And then they put a note on your record. You get too many of those strikes, and we kick you out of the college. Do not cheat. I will find out. This is not my first rodeo. The rest of this you can read on your own. It is just, hey, what is this class about? These are the things we're going to cover. Yada, yada, yada. So. Oops, do you want to save the changes to the syllabus? No, I did not mean to strike through the syllabus. All right. Let's see here. On this page, I have some general tips for being successful in this class. The most important thing to be successful in Chem 161 is to not let this class get away from you. Chem 161 is very deceptive. Just like Chem 140, there was like that middle portion where it was like, wow, we did all the hard math at the beginning and all the hard math that came at the end. There was like that middle part where it was just easy. Chem 161 sort of falls into that same sort of trap. And that is, the beginning is all review. And so for the first 3 weeks, we're going to be doing stuff that is familiar to you. None of this should be super new. There are a few new things here and there. But for the most part, it should all be content that you've already covered in a previous course. And then we hit chapter 3, and all of that goes out the window, and then holy shit, this is hard. I cannot stress enough, when we get to chapter 3, you have to put in the time for this class. So putting in time in this class is the most important thing you can do. Make sure that you aren't just coasting by until you get to chapter 3, because it's going to come back to haunt you. I've seen a lot of students who did well enough in 140, like they got a B or whatever, and then crash and burn in 161 because they were not expecting chapter 3. I've seen A students crash and burn. Like, they still got A's, but they still had a crash and burn, like, crisis moment where they're like, holy shit, I was not prepared for how hard chapter 3 is. Chapter 3 fucking sucks. We're going to get through it together, but just fair warning. We're going to be in chapter 3 hell for like 4 weeks. So, what can you do to alleviate or at least mitigate how difficult this class can be? And I have some strategies here on the board here. So the first is, I gave you this OER textbook, and it's actually really good. Please read the textbook. I know that I say that, and every instructor says, please read the textbook, and nobody does, because nobody gives a shit about the textbook. This one's free, and it's actually worth looking at. The intent of the textbook is to expose you to the material, such that once you have seen the material enough from different sources, some of it will stick in some capacity, and you'll understand it at a rudimentary level. That could either be the textbook or me or other students or other sources or YouTube or whatever. But exposing yourself to as many different sources of content is important for your learning. And the more sources that you have for that, the better. So the textbook is one of those, so please try and use it. If you have read the lecture already, you're probably going to have questions. Bring those questions to me as we get to those topics. If you ask me like during the interstitial parts, like before class or during the break, totally valid. I can help you with that. Or I might say, hey, we're going to answer that in a little bit. See if that answers your question. And if it doesn't, then we can keep talking about it. Homework problems. Do all the exercises. Do as many as you can. I cannot stress this enough. Do all the problems. You need the practice. And then finally, ask as many questions of me or others. So we'll underline this too. As you can. It is super, super important that you don't go this alone. I am a resource that you can use. Other students are. You have the class Discord. Talk to each other. Talk to me. The more networking you do, the better this will be. How much time do you need to put into this class? We have collected data from 161 students all over the college, also all over the state and the country, because Chem 161, everybody takes this class for chemistry, bioengineering, etc. And the data that we have collected from like Chronicle of Higher Education and stuff like that has done numerous studies on this. To get a C, the amount of work that you need is 2 hours per day, or 14 hours per week. That's to get a C. Nobody wants a C, right? Everybody wants an A. We want to be A students. So if you want to be an A student, you're going to have to put in more time than this. So what that means is that timing is everything. Is there a way to get an answer key for the questions for the homework? Yeah, so the answers in the OER text are highlighted in the problems. So like if the problem number is blue, you can click on it and it will take you to the answer key. Just hold Control Tab and click on like one of the blue numbers. And it'll open the answer key in a new tab, so you can refer to that. The even problems, I believe, do not have answers, and I don't have those answers available. So if you have a question on any problem, I'm happy to answer it for you. So like if you show me your work, I can look at it and say, yeah, you did this correctly. Or, oh, you lost a unit here, so this didn't cancel out, and then you have a mistake, or whatever. I can definitely look through that sort of stuff. So yeah, doing the homework, reading the textbook, doing any of these things, like study group, office hour, these are all super useful resources because they are exposure time to the content. Just like cooking is not a skill that you can immediately go into the kitchen and masterfully do. I dropped my pen here, so I'm trying to grab it. You don't go into the kitchen and be like, oh, look at the quiche I made. It's so good. Or look at this filet mignon. I'm a perfect chef after... How long have you been cooking? Oh, 20 minutes, you know. No, nobody says that. The first food that you ever make is shit. And I know that because I was a college student once too, right? I didn't know how to cook. I was all frozen pizza and ramen. And then when you actually have to prepare real food, you're like, how the hell do I do this? And you make mush because you overcooked it or it's raw in the middle or whatever. So... And that's purely a function of, hey, I haven't been a cook for very long, so I don't really know what I'm doing. All I've done is watch Food Network, which does help, by the way, because you are looking at something educational and spending time with it. So if you study by doing any of these things for any amount of time, that all adds together cumulatively and helps you. The real trick is going to be hitting this milestone. Can you provide yourself with 14 hours per week of time, or even more than that if you want a higher grade? Because if you're working 40 hours a week, and then you're going to be doing 14 hours on top of that of study, that's a pretty intensive week. You got to have time for sleep, and you got to have time for you to unwind, right? So be careful, that is what I'm saying. If you are already taking 16 credits and you are working 40 hours a week, this is a 5.5 credit course. This is essentially half of your workload as a college student. This is a 20-hour job, is what this class is. And if you don't have enough time, you're not going to make it. And I don't want that. I don't want students to not make it because I see tons of people not make it through these classes. And it's not because my students suck. It's because they don't have time. Nobody really at this level sucks. If you get to college and you're taking these classes, it's generally because you want to be here for a reason, And if you have even that little bit of incentive or motivation, you can do this. You just need enough time. Some people may need more time than others, depending on like what your interests are. For example, I'm not a humanities major. If I was taking a humanities course and like doing literary analysis or whatever, I would need more time to study. I would probably have to study more like 20 hours a week to get an A. As opposed to chemistry, where I could just absorb this stuff and it would take me 6 hours a week probably of study. Your aptitude will be different based on your interests, but the end result remains that you're going to have to put some time in to this class. And I want to make sure that A, you're aware of that, and B, you have enough of it. Because I want everybody to be successful. I get no pleasure out of failing people because they didn't make it. That is not a thing that it makes me happy. So, all right. We're at the end of the syllabus spiel. What I'm going to do, we're going to be in this together for the next 10 weeks. We're going to start by going straight into a break. I take a break every 10 minutes. Every 1 hour, we get a 10-minute break because this is a union job. No, it's because if you are sitting here listening to me yabber for 2 hours, you tune out after about 45 minutes. So you've probably already tuned out already. So instead, tune into this wonderful music. From this week's music is Tunic, a cute little game about a fox who runs around, and it plays like Dark Souls. But there's a little bit more under the hood, and I loved it. I finished it I finished one of the endings on like Thursday, so we're gonna listen to more music for that. So I'm gonna turn on the timer here, and we'll check back with you in 10 minutes. Alright, we are back. I apologize, I didn't realize I didn't have my mic muted. Which meant that you're probably hearing me, like, you hear this crinkling of, like, candy wrappers because it's Easter and I'm a glutton for Reese's peanut butter eggs. So, alright, I've loaded the slides for Chapter 1. So, let's get ready for chemistry. So, chemistry, Chapter 1... Ah! Why did that happen? What is going on? Sorry, hold on. My computer's possessed by a ghost or something. Where's my stylus? There it is. I don't know what that was all about. What the heck? Why is my slide... Hold on. It's like going back and forth on its own, and I don't understand. That's very strange. Okay. Anyway. I'll just hit the spacebar. Okay. So, what the heck is going on? Okay. My PowerPoint is inhabited by a ghost or something. Okay. Anyway. All right. What is chemistry? Chemistry is the study of how matter interacts with other matter. So, for example, if I put matter A and matter B together, will they react? Ideally, we will want to devise matter A and matter B to do what we want. So, for example, if matter A is your body and matter B is clothing, we don't want a reaction there. So we need to study what the properties of, like, say, your skin cells are versus what the properties of polyester or polyurethane or cotton or silk or whatever, to see, like, oh, okay, am I creating something that is reactive with other substances? Versus if I devise a medication, I do want it to react with certain parts of the body, but not with others. So how do I make this work? We've been studying chemistry for a very, very, very long time. So if you go all the way back to before the Common Era, so before the year 0, the ancient elements were considered to be these 4 things here. I have the alchemical symbols of them on the screen here for air, water, earth, and fire. There is a 5th element. That's Lilu. I don't know if you've seen the 5th element, but it very important, very important element. It took a long time for people to realize that these 4 fundamental forces, we'll call them, or the elements that sound like they come out of a Final Fantasy game, which is where the term comes from. It comes from chemistry. Haha, Final Fantasy is related to chemistry. All the elements. It took until, like, the Renaissance era for people to start putting things together. Yeah, multipass, there you go. It took people very, very long before they started to realize, like, hey, wait a second. There are way more elements out here than just fire, water, air, and earth. In fact, these aren't even elements. Well, water isn't. Water is a compound. There's stuff in these substances, and we can do reactions with it. And so this is where alchemy started. So the foundations of alchemy are actually just chemistry. We like to romanticize alchemy as, like, transmutation and turning, like, lead into gold and stuff like that. And what we're going to learn over the course of Chem 161 through Chem 163 is you can actually turn lead into gold. It requires so much energy that it is not worth it. For example, turning lead into gold is a nuclear reaction. The ancients certainly didn't know that, and then the people in the Renaissance era certainly didn't know that. So there was no way that they did this because they didn't have access to nuclear reactors and stuff like that. But what they did have access to was basic chemistry, and they learned a lot and realized that once they started writing this shit down, they could keep that knowledge and give it to future generations to work with and build upon. And so that gets us to all the way to the present era. This is the Kovacs lab. The Kovacs laboratory was right across from where I worked, which was the Goldberg lab. In 2000, when was it I in there? 2006, I believe. No, that's when I started. 2009 was when I finished my degree. So this is 2018, and the Kovacs lab works with basically they do inorganic and physical stuff, I believe now. And that's at UW, so you could go there and see this setup for yourself. But along the way, we have followed more or less this very structured sort of idea machine, I guess we'll call it. And it's called the scientific method. And what we have done with the scientific method is we have established ideas that have become the core of all of the different sciences that are around us. Now, a lot of people in this class are probably not in here to be chemists. In fact, I think almost nobody is, by my reckoning. We get very few pure chemistry majors at Everett Community College, which makes all of the chemistry faculty very sad, actually. But most of you are probably here for one reason or another. I would assume that the majority of you are either up here or I was trying to find just general engineering and but like so that would be more like over here. Here's engineering. So here or here. So those are probably the three most relevant majors from my perspective that are at this college. And if you are there, you're going to need chemistry because chemistry feeds into all of these things by being a basic like physics and chemistry are very closely related. Chemistry is applied physics. So physics is interesting on its own and has a lot of unique properties and concepts and stuff like that. But then chemistry takes those and does something else with them, and that is very important for things like chemical engineering and material science. Biology is applied chemistry. So if you want any understanding of biology, you need to know how chemistry works. Because biology takes all of the things that we learn in chemistry, puts them in a context, and then runs with it. Biology is basically the word problems of chemistry, whereas chemistry is the word problems of physics. You know, the stuff that's harder and it requires more context and there's more stuff involved. So chemistry is often considered the central science, but I actually think that that's really pretentious. All of the sciences are all inextricably linked together, and they're all important. So getting a little of everything is useful. I'm not going to sit here and be like, chemistry is the most important science. I personally just think it's the most fun science. And the reason for that is biology is kind of too conceptual. Like, that's cool and all to see how cells work. And then physics is too math. Like, chemistry is sort of like the middle ground of both, which unfortunately, in my opinion, makes it the hardest one. Like, not hard in like a like, ooh, I'm chemistry. I'm better than everyone who does these other majors. No, it's just it's more difficult to like get a grasp on all of the concepts because people tend to be towards one side or the other. I tend to be more towards the physics side of things. I'm more of a physical chemist than a biological chemist. So if you ask me like I don't know, to describe physical chemistry stuff like quantum mechanics and thermodynamics and kinetics and stuff like that, I can do that super well. If you ask me to describe like how does a cell work, like fuck if I know. So that's where we are in the grand scheme of things. Your mileage may vary based on what your career intent is and your degree path is, but our intent is to give you enough information in these courses so that you can then function. Yeah, that's the one thing I know about the cell. The mitochondria is the powerhouse of the cell. Everyone knows that. I don't even know what that meme's from. Is that from like Idiocracy or something? But everybody knows that. Now, chemistry is important because it's ubiquitous. It's everywhere. If you take your phone, so I have my phone right here. The LED screen that is projecting color at you is emitting various wavelengths of light, which we're going to talk about in Chapter 3. It's powered by a battery, which is Chapter 16. We'll do that in 163. And all of the materials that went into making it, so the plastic that was made for the outside, the specific layer of glass that's on the cover, I don't really know what else goes into the phone other than like a circuit board. So the silicon and stuff like that was all constructed and engineered in a very specific way, and it all requires chemistry. Food contains energy that you digest. You get energy through chemical reactions. when acid breaks down the food in your body, those components are then sent to your intestine, which absorbs them, and then your cells do different reactions, and the stuff gets oxidized, and something mitochondria. I don't know. So there are so many different reasons that we would want to study chemistry. So most students have to go at least this far, and then they stop. Some students will stop at 163, and if you're in biology, you get to take all of them. So this is bio, and over here is engineering. And depending on what flavor of engineering you are, you might go to 162 or 163. So, haha, biologists. You get to do all the fun stuff. I love organic chemistry. I wish I got to teach it. Everybody else loves it too, though. So hopefully you will find some of this stuff that we're going to talk about in these courses to not just be relevant, because, I mean, it has to be relevant. That's why we're making you do it. But also just interesting. Scratchy throat. Give me just a second. I'm going to open my seltzer water. We got lime today. When we go back to campus, I'm going to have to start bringing polar seltzer because I don't drink water anymore. I drink seltzer water. Thanks, pandemic. You've turned me into a late 30s person. Seltzer water is really good, though. All right, here's our thinking machine. I'm calling it a machine because it follows like a regular sort of cycle. So like an engine, when you turn the crank on an engine, it goes in a very predictable and regular pattern. So here's our thinking machine. We are going to input observations and ideas into the thinking machine. And what's going to happen is we are going to do stuff with those ideas. And the things that we're going to do are the following. The first thing that's going to happen is we're going to form some sort of prediction about a problem. And that's called a hypothesis. A hypothesis is just a guess or some sort of assumption of what will happen when we do a problem. So if we make observations, for example, like, oh, I drop things and they fall down. You could hypothesize that everything's going to fall at the same speed because it's being pulled down by some force. What the next thing that you would do is in the machine is you would take that prediction and you would test it. You would devise some sort of experiment that would test how things fall down. So I would just grab a bunch of things and then I'd drop them, and that would be my experiment. And during the experiment, you would gain observations and collect data. All of the data that you collect during the experiment helps you define a results and conclusion. What were the results of the experiment where I dropped things? Oh, look at this. If I drop paper versus if I drop like a book, the paper falls super slowly, but the book falls down really quickly. But if I crumple up the paper, it falls really quickly. That's strange, right? What's going on here? So not only have we answered some questions, do all things fall down at the same speed? Well, no, they don't. There's something else at play. Now we have some ideas. Why does the paper that is unfolded fall slower than the crumpled paper? They have the same mass, but they have a different surface area. So that's got to be some part of it. From all of that stuff, so once we've made all of these observations and we've got our results and conclusions, I can't spell. Conclusions, I guess. I don't know. Conclusions. There we go. Then we have two things that we can do. The first thing that we can do is we can take that and refine our experiment. We can get more information out of it. So we can start testing things with high surface area. So like maybe like a really big piece of paper versus a feather versus a ball versus a rock or stuff like that. And so we can refine the experiment and get more and more and more information. The second thing that we can do is we can take our results, and where'd my pen go? I lost my cursor. There it is. We can take our results and we can start just accumulating them. as we accumulate results, we can ascertain that they are what we would call true. I did this and this was the outcome. That is true. We're going to call that a scientific fact. A scientific fact is some observation from an experiment that we noted as true. When I dropped this object, it fell slowly. That is a scientific fact. If I get something that does not support the hypothesis, then I cannot accept the hypothesis as scientific fact. If I drop this, and if I drop this, things fall upward, is not a valid scientific fact because it is not supported by experiment. So we need to be doing experiments and collecting data that produces true observable results that are also reproducible. As we gather a body of scientific facts, we can turn those facts into one of two things. If I do several simultaneous similar experiments alongside my original one, and I notice a consistent behavior, I can devise something called a scientific law. A scientific law is basically an overview of how matter behaves. How does matter behave? Matter is attracted to other matter. It falls in the direction of other significant matter. For our purposes, that's the Earth. The Earth is the most significant form of matter. All objects fall towards it. If you were in outer space, that would be different. Objects do not fall towards only Earth. They fall towards the sun or the moon or Jupiter, depending on your specific location in space. But all objects will fall towards the largest source of matter around them. So that would be our law. Now, why does this happen? Well, we would need more information. We would need to do other experiments. And that can generate something called a scientific theory. A scientific theory tells us why matter does this. Why does matter fall towards the other larger matter that's around it? And the answer to that would be, well, gravity is involved. Gravity is a force that is exhibited by all mass. So gravity would be involved in our theory of why this is happening. Now, what is the theory of gravity? What is causing gravity to happen? It's still unknown. Isn't that nice to know something as basic and simple as gravity? No understanding of it whatsoever? How do two things see, quote unquote, each other with gravity and know to be attracted to each other? We don't know. We don't know the answer to that. So, if you're curious about that, maybe that's a question you'll answer one day, because I'd sure like to know. I'd sure like to have a model for why space bends and how objects see each other over a distance, like find the graviton, that sort of thing. Like, that'd be really cool. But those things don't exist, as far as I'm aware, because we just haven't discovered them yet. So there are scientific topics out there that are extremely relevant to us and extremely basic, but we still don't know the answer, because the answer is shrouded in very complex mysteries. So science is always nebulous and interesting in that regard. So let's define these terms. Oops, I hit the wrong button. Sorry. I hit the wrong button again. There we go. Let's define these terms in a little bit more detail. So a scientific fact is going to be something that you can observe in an experiment, and you observe it every time you do it. That means that it's reproducible. If you do the experiment multiple times, you should get a result that is consistent. They may not be exactly identical, because we're going to do different experimental setups here. But what we're going to do is we're going to add sodium to water here. My browser is up to date. Thanks, YouTube. Now stop that. Just open the damn link. There we go. Oh, I don't need this over here. I got to capture this window. There we go. Boop. All right. So we're going to look at experiment 1 here. All right. Tell me what happens when we react sodium with water in this fashion. Here we go. Yay, that was exciting. So something happened. We dropped the sodium into the trash can full of water, and then boom, right? All right. That was experiment 1. Let's look at experiment 2. That didn't actually do anything. There we go. All right. I understand and wish to proceed. I don't know why this video isn't inappropriate. YouTube, stop it. YouTube, I'm trying to teach. Thank you. There we go.
Disgusting.
Alright. This is a very professional video. I have no idea why YouTube is flagging it as inappropriate.
Yeah, no explodies.
The longer it takes, the farther back they get. It takes a Jeez.
So, I don't know if this is faked or not, but you could see that when they put the sodium in the water, you got a nice little explosion out of it, despite these people being very, very unprofessional. Let's look at experiment 3 here. So I'm going to put the sodium in the water. There it goes. Now you might notice that experiment 3 is a little different because it didn't really explode, but it definitely caught on fire. The major difference between experiment 3 and the first 2 experiments is that we did it at a very small scale. It's hard for it to explode if there's just not much around there, right? So, what's the deal with experiment 3? Is it similar enough? Let's conclude that it is for now. So, we'll just cover that back up. So, the observation that we would make, the scientific fact that we'd observe, let's just be a little more general about it. Sodium reacts vigorously with water. That's the observations that I would personally make. And that would qualify as a fact for our purposes. If you said that, no other scientist who has done this experiment would disagree with you. So therefore, it must be a scientific fact. Now, if I want to make a law out of it, I need to find a relationship between matter and this phenomenon. And I need to be able to explain that in the sense that, like, all material of this nature does this thing. So let's try and do that here. So we're going to look at different elements here. So I'm going to look at potassium here, which means I got to put this back on the screen. Here's potassium. I said here's potassium. There we go. All right. That was potassium. It goes real fast. But if you look at how it reacts compared to sodium, it's pretty similar, isn't it? So here's sodium. We'll look at sodium again. So yeah, those were pretty much the same sort of reaction, right? We dropped it in the water, it caught on fire, it burned a very bright color. Let's see rubidium and cesium. I don't know if this is the crappy video or not. Yeah, this is the old one. I don't want this one. So let me do this. Let me get the next one on here, rubidium. So there's cesium. We'll get that in a second. And then I want rubidium. Where is it? There we go. All right, so here's rubidium. We're going to drop it in the water. Kind of the same thing, except really fast, right? It just turns into this little bowling ball of death. All right, that was fun. And then finally, cesium. Blink and you'll miss it. Here we go. I hope you enjoyed it. It was great. Sounds like Duck Hunt or something when it does that. There's the freeze frame of the one frame that it was available. So, what you've probably noticed is that if I'm all these elements that I'm pulling off of, Oh, NaC alloy is dangerous. Yeah, we're not going to talk about NaC. NaC is ridiculous. What do I want to do here? I want to do this, and then I want to go to p-table. And then we'll put this back on the screen. That's not helpful to me. So sodium-potassium alloy is actually as reactive as sodium or potassium independently. The reason that it appears to be more reactive is because it's a liquid versus a solid. And liquids have way more surface area. So you get a much cooler reaction. Cesium is super explosive, though. If you liquefied cesium, it would be pretty disastrous. Here's our periodic table. You've probably noticed that all the elements that we were choosing were these guys. So here's sodium, potassium, rubidium, and cesium. There's no francium out there because francium is radioactive. It doesn't last very long. So if you dropped it in water, it wouldn't be francium by the time it got there, probably. We can definitely look at lithium. Lithium's kind of boring, actually. So let's see here. Lithium in water. Oh, I realize I have this. Hold on. Wait, doesn't this guy have lithium on his page here? Hold on. Oops, sorry. You can hear the cesium again. That's great. Lithium. Yeah, there we go. Okay, so we'll just do that. I mean, you can't see it. It's not centered properly. That's okay. So there's our lithium. Now, later on, we're going to try and, like, predict a pattern of all this stuff. Like, why did lithium burn the slowest? Why did sodium burn the fastest? We're actually going to be able to answer that in this class, which is kind of cool. Oops. Sorry, hold on. I clicked over on my live feed, and it was like, do you want to exit the stream? I was like, no, I don't. What is wrong with you? All right, so the scientific law that we would observe for those reactions is that, okay, all those elements that we chose that were on, let's see here, we'll click here. On our periodic table here, all of the elements in column 1A, or column 1, I should say, all reacted similarly with water. When you put water in, or introduced water to them, they reacted violently and exploded. Which is interesting. Now, why does that happen? That's not the scientific law's job. The scientific law cares only about how the matter behaves. And so our observation would be elements in group 1 explode on contact with water. So there's the difference between our fact and our law. Facts are specific to any one given experiment, but laws apply to a whole bunch of experiments and try and attempt to collect that information into one generalized description. Finally, we have the theory, and the theory builds off of all of this to try and explain why. So, why does this happen? Now, in order to determine a scientific theory, we need to do different experiments. So we cannot just do the same experiments to collect data for a law. We need to do other experiments that tell us why is this happening. We're going to learn about this in Chapter 3. Elements that are in column 1A, sorry, group 1 on the periodic table for the new numbering, they are explosive because when you drop them in water, the water oxidizes them and removes the electron that is present. There's only one s electron in the valence shell of the elements on that column. And it's very easy to remove and form the ion. And when you do that, you gain energy. The system gains energy, or I'm sorry, the surroundings gain energy. So that energy is then shown as explosions. Now, if none of those words made sense to you, that's totally fine, because we haven't learned any of this stuff yet, right? So we're going to learn what an s electron is, or what it means to be exothermic versus endothermic, or what ionization is. That's all Chapter 3. So we're going to get there. But the point is, the scientific theory is telling us, Here's why what you saw happened. So, a scientific theory is extremely important. If you hear somebody say these words, it's just a theory, probably followed by these words, a game theory, that person is misusing the word theory and doesn't understand science, okay? So don't go around saying, "Oh, it's just a theory." No, a theory is hot shit. Like, a theory is very important to our understanding of the universe. I actually hate the game theory guy because his shtick is to just misuse that word. And as a scientist, that bugs me. So don't be like that. All right. So there you go. If you hear someone say it's just a theory, that means that person knows nothing about science. So you can point. You have my permission to point and laugh at them. All right. Do I have a homework practice for this? I don't. Okay. So what I want you to do on this slide, I'm going to give you like 2 or 3 minutes to tell me in this set of not rules, but observations here. So I'm going to go like this. I can't find my cursor. There it is. 1, 2, 3, 4, 5, 6. So in each of these experiments, what I want you to do is the following. For experiment A, I have hidden a fact, a law, and a theory in one of each in that experiment A. Tell me what is statement 1? Is statement 1 the fact, the law, or the theory? Is statement 2 the fact, the law, or the theory? Is statement 3? And then down in experiment 3, I have also done the same thing. Okay? Use what you can tell from the context of the problems to decipher which one is a fact, which one is a law, and which one is a theory. Remember all of the things that we've talked about, how facts are one experiment, laws are a bunch of experiments. Laws tell you how stuff behaves, theory tells you why. Okay? So you should be able to deduce it from that. Type your answers in the chat. We'll go over them together in about 5 minutes. So I'll see you then. Let's do one more minute and we'll go over the answers. All right, let's talk about these. So remember that a fact is just an observation for a given experiment. So fact is one experiment. It's a specific observation. So I'm going to look at experiment A, and I'm going to try and exclude things that sound like they refer to too many experiments, right? So if I look at statement 1, mixing boiling water and cold water makes a solution that's lukewarm. That's one experiment that could be done. So 1 could be the fact. Statement 2, the final temperature of 2 objects in thermal contact. That automatically should tell you, well, what are the 2 objects? They could be any combination, so 2 can't be the fact. And then 3 doesn't talk about an experiment at all. So 1 must be the fact. A law is a generalization, and it tells you how matter behaves. Whereas the theory is very specific as to why matter behaves how it does. So now it comes down to which of these sounds more like a how, and which one sounds more like a why. And so the answer is that number 2 is the law, because it explains how matter behaves. When you have 2 objects that touch each other, their temperature becomes the average temperature. Now, why does that happen? That happens because the heat moves through molecular vibration. So there's our explanation. See, it's difficult. I know a lot of people looked at number 2 and were like, oh, that's the theory, but that doesn't tell you how they get to the average temperature, does it? It just tells you that they do get to the average temperature. Why would that happen? Well, the temperature difference occurs when matter vibrates, and then eventually everything will be vibrating at the same speed because that energy will be passed between all the different molecules. All right, let's look at experiment B. We're going to do the same process. Which one looks like a specific one experiment? To me, that's number 5, because we're looking at a flower versus vegetables and fruits, which there's lots of. And then we have plants here. So number 5 must be the fact. So if I give my plant distilled water, it will thrive, but I get salt water, it will die. All right. Which of these tells me a generalization? So statement 6 tells us areas with high concentrations of ions in the soil, the plants do not grow well. Now, why is that? Well, it doesn't say that, so this must be the law. And that makes the theory number 4. Sodium chloride mixed with water is toxic to plants because the high concentration of solution forces water molecules out of plant cells. It forces a process called crenation, which is the cells dehydrate and shrivel and that's obviously no good for plants. Not all plants experience this. Like seaweed is fine, but like a daisy or most trees would struggle to live in an area with high concentrations of salt salinity or soil salinity. Salt salinity. All right. So that's how we do this. You're going to be looking through these statements and you're going to be looking for these key features of them that tell you, oh, this is one specific experiment. Oh, this is a bunch of experiments. Oh, this is why this is happening, that sort of thing. Do not fall for the trick of, oh, the longest one must be the theory. However, a good thing to look for is if you see this word, if you see the word because is a great indicator of a theory. We use the word because to start a sentence that explains the previous sentence, right? I went to the store today because I ran out of food at home. I drove 16 miles to work because that's my job, right? The after because explains the previous thing. Now, is this going to universally be true? Not necessarily. However, most cases it will be. If you see because, consider that one to be the theory. All right, any questions, let me know. All right. The last thing that we're going to talk about today in this section is just these 3 different things that you see on the screen are called domains. And I'm just going to highlight them all here. We're going to represent matter around us in 3 different manners. The first one is what you and I can see. Something is macroscopic if it is our sized. So, for example, this glacier, or the ocean or sea that it's sitting in, and the clouds around us, is macro scale. We can observe it with our senses. Something that is micro scale exists, but we cannot observe it with our senses. We need to use either tools to do that, or we have to basically imagine that it is how it is, using our belief in scientific fact and law and theory. So, on the red box there, I have shown the different orientations, we'll say, of water molecules in different states. So in the gaseous state in the clouds, the water molecules are distant and separated all apart. In the solid state, they are arranged in a very particular manner. And in the liquid state, they're all just sort of jam-packed together. It is impossible for us to visualize this using a tool because we don't have stuff that lets us see individual atoms moving at a speed that we could perceive. It would just look like a mess. So what we have to do is we have to imagine that this stuff is how it is. But we are basing our imagination in fact. So we're not just playing make-believe. We're not just making shit up. The last domain is the symbolic domain. This is just our way of writing out these phenomenon in a manner that we can communicate it. So if I said, oh, it's water vapor, but I didn't want to write the word water vapor or draw a picture, I could write this. H2O with the G after it for gaseous. So these are the 3 domains that we are going to follow. We're going to primarily concern ourselves with the microscopic domain and the symbolic domain. And I have 7 minutes left. How much time do I... Hold on just a second. Let's see here. What can I do in 7 minutes? I can probably do 5 more slides. Okay, so we'll do that. All right, so before we go for today, I'm just going to talk about the 3 phases. We're going to define matter as anything that has these 2 properties. These properties are not our. Anything that occupies space and has a mass to it, we're going to classify as matter. Anything that does not occupy space or does not have mass is going to be classified as something else. Primarily, we're going to be studying energy. So, for instance, heat. Heat is not a phenomenon that has mass. You can't weigh heat. If you have hot water and cold water, they weigh the same thing, but one has heat in it and the other one doesn't. What's the deal there? What do we do? Well, it's because the hot water has energy in it. And so energy is different from mass. So energy is not matter. The three phases that we're going to care about are solid, liquid, and gas. We're going to define those on the next slide. Other phases exist. We're not going to really talk much about plasmas, supercritical fluids, Bose-Einstein condensates, things like that. There are tons of different phases out there. We're going to stick to the common three. Here's our manner of defining phases from each other. We're going to use the principles of shape and volume to help us gather information about molecular states and arrangements in the given phase. So in a solid, all of our molecules are basically locked in place, so the shape remains fixed. As a result, its volume is fixed too. In the liquid phase, all of our molecules can move around freely, so they can create different shapes, but they are all bound to each other, and those, they're not bound to each other in the sense that they're bonded, but they are all attracted to each other, and so they retain a shape that is then constrained by gravity and pulls it towards the bottom of whatever container it's in. So the volume of liquid that we have will always be fixed, but the shape will be the shape of the container it's in, so therefore it's variable. And then finally, a gas simply occupies the container it is in. If I open the container, the new container is whatever surrounds the gas. So if I'm in a closed room, the room becomes the container. And if I'm in an open room, the container becomes the earth and the atmosphere. So gases occupy whatever container they are sealed in. And then the last thing we can talk about for distinguishing matter is that there is an important issue that arises, not with this term volume, but with the term mass. Mass is the amount of stuff something has. So like all of the atoms that are contained in your body is your mass. Now, another term that comes up when we talk about mass is the term called weight. Weight and mass are not the same thing. Weight is a function of gravity that you may have seen if you've taken a physics class. So here's the formula for Newton's law of acceleration, F equals ma. If you've taken a physics class, you've seen this before. Now, what do these terms mean? So m here is our mass. A is an acceleration due to a local phenomenon. In this case, it would be gravity. And then F is the force or the weight. So let's look at an example of that using this astronaut here. If you were an astronaut that had a mass of 100 kilograms on Earth, you would have a weight of mass times gravity, or 980 newtons. But if you go to the moon, your weight changes drastically because there's much less gravity pulling you down. Your mass, however, remains the same. You have 100 kilograms of stuff in you, regardless of where you are in the universe. But the act of the local gravitational field accelerating you towards its core affects your weight. So be very careful. The reason that I bring this up is that in the laboratory assignments you're going to see in this quarter, and then in future quarters when presumably you have lab, is that if I ask you to determine something's mass, the term that we use to do that is weighing. And my pen isn't selecting the thing. There we go. So if you want to determine something's mass, you go weigh the object. And that's confusing. And that is sort of a scientific, I guess, relic, I guess is what we would say. It's not a term that I would like to use. I would say, like, go mass the object. But colloquially, what we just say is we go weigh the object, which is just unfortunate, and we'll just have to deal with that. So be very careful that we don't mix up mass and weight. So those are some basic introductions to matter and stuff. We're going to continue our discussion of all of this on Thursday when we get into sorting out and compartmentalizing different categories of matter, how we can change matter, and then finally some calculations that are very basic that we can do involving matter. I do want to thank everybody for coming out to the lecture. Lectures will be from 2:30 to 4:30 or 4:20 on Tuesday and Thursday. I have updated the syllabus to reflect that, so I uploaded a new one. You can download the new copy if you want. The correct time is posted at the very top of the syllabus, so should be okay. Nothing is due just yet other than the orientation quiz. Make sure you get that done by Friday. That's all I got. I guess we'll see you on Thursday. Make sure to ask me any questions in the class Discord or email. Take care.